Busy bees buzzing from their hives. As summer fades, their work collecting nectar to feed a new generation of honeymakers is almost over for another year. But in the UK, honeybee numbers are falling fast. And nowadays, when beekeepers check their colonies, they dread the scale of losses they'll find.
Last full winter we've been able to measure, that's 2007-2008, we were at over 30%, and in some areas in the country, way more than that. And that's very serious. You're losing nearly a third of your colonies.
The decline led to a 50% drop in home-produced honey, which ran out in the shops by Christmas last year. But there's a great deal more at stake than a tea-time treat when it comes to the health of bees.
It isn't just about honey, it's about pollination, and the whole nation depends on pollination. And taking on the global scale, honeybees are absolutely fundamental pollinators.
No one knows better than farmers the importance of bees to growing crops.
Things like apples and soft fruit, for those crops, the pollination is very much dependent upon honeybees, probably around 90% dependent.
Honeybees contribute $300 million worth of crop pollinations to the agricultural economy in the UK and are estimated to carry out half of the pollination of other plants, on which ultimately all the rest of wildlife depends. Bees play a vital role in the food chain, responsible for 1 in 3 of the mouthfuls that we eat. Scientists working to reverse the decline may dismiss apocalyptic scenarios, but they are investigating the disappearance of hives around the world, including huge losses from so-called colony collapse disorder in the United States, where pollination by large commercially managed bee businesses contributes $15 billion of value to agriculture. Research is focusing on viruses, diseases, and in the UK on a particularly destructive parasite, the varroa mite, known to Britain's army of mainly amateur apiarists.
For the first 10 years, we were able to treat them quite simply with little pyrethroid strips that we used to put into the hives. But the mites are now becoming immune to those strips.
Working on solutions at this unit at Sussex University, researchers hope selective breeding will produce a bee which will rid itself of parasites and diseases, using a natural trait called hygienic behaviour, where bees throw a sick larva or pupa out of the hive before it can spread the infection. The very latest genetic techniques are being employed, targeting not just specific colonies, but individual bees.
By actually observing their hygienic behaviour and then looking at the genotype of those bees, looking at their DNA, we can hopefully speed up the breeding process, and that technique should be applicable elsewhere in the world.
Public interest in the honeybee issue has been growing steadily, and a national campaign bore fruit this year when the UK government pledged $15 million of new funding for research into pollinators. Besides pests and disease, the finger of blame has been pointed at global warming and even phone masts, and environmentalists are calling for a ban on a group of pesticides which beekeepers are also concerned about.
Pesticides have the potential to do a great deal of damage, and the newer pesticides, the neonicotinoids, need to be looked at a little more closely.
But farmers and the UK's only professor of apiculture dismiss any link with the bees' problems.
Where insecticides are used correctly, they do not cause major problems. In Britain, for the last 5 years, we've not had a single reported incident of a major pesticide kill caused by insecticides on honeybees.
It's a view echoed unsurprisingly by manufacturers such as Bayer.
Where these products are used in large amounts, and I'll give an example of Australia, they have no problems with bee health. And in places in France where they have restricted the use of neonicotinoids, they are still seeing exactly the same problems with bee health as where they are being used.
And while the search goes on for a solution to the mystery of the disappearing honeybee, a commercial breakthrough will be costly and time-consuming.
You first, of course, have to find something that you think may be active on a particular thing, in this case a varroa mite. It then costs somewhere in the region of about $200 million to bring a new product to the market. And it'll take you somewhere between 9, 10, 11 years to actually do so.
Beekeepers, farmers and honey lovers everywhere are not alone in hoping it won't be too late to ensure the survival of a creature vital to the food we eat.